OCI database overview. In this lesson, we will discuss the considerations of running a database in an on-premise environment as well as in the cloud. We'll also learn what are the supported types of Oracle databases. In an on-premise database, the administrator will need to perform various tasks in the on-premise data center. It will be the administrator who would need to monitor the utilization of resources to ensure that there is sufficient resources to handle the workload and to adjust it accordingly to meet the demands. Well, this has to be done manually, so that's a consideration of scalability. Though there is scalability capability, it's all in the hands of the administrator. The administrator will also need to maintain the servers that are running the databases and the applications. The administrator will need to make sure that the servers are not running on outdated hardware as well as software, especially if there are unpatched software that will be prone to vulnerability, causing compromise in security. This will be considered lack of flexibility. It will be the responsibility of the administrator to upgrade the enterprise system without shutting down the entire system. That may be very challenging, as many of the older servers does not have that ability to be able to do online upgrades. That will be a consideration of the lack of availability when trying to do server upgrades. It's the administrator who's going to be challenged to maintain the cost of running and maintaining servers, especially servers that are outdated. Along with running an outdated hardware and software that can lead to business to lose revenue, the other consideration would be compromised security. More money would be then required to address that breach in security, along with the cost of maintaining the hardware and software. So this will be a consideration of an increase in cost. Providing access to the resources can either be the server, the database, or even the applications. And that's the responsibility of the administrator. It can be a daunting task if the company has tens of thousands of users. So lack of ease to provide that accessibility can and may be a challenge. So when you take all that into consideration, it's really paramount for the administrator to ensure the availability of your servers, be it the actual server, the database, or the applications. You want to make sure that it can grow, it can scale to address all the workloads, that it is flexible, that it can continue to grow in hardware, software, as well as stay current with security, and to be able to upgrade without needing to have the system become unavailable, and to maintain costs and to continuously make sure that who needs resources does by accessibility. So all this taken into consideration is and may be a challenge for the availability of your database to all your users that need to perform by the administrator who performs all these tasks. Let's take a look at the many benefits of running your database and application in the Oracle Cloud. Instead of the on-premise administrator doing all the tasks, it will be performed by the service provider, in our case, Oracle. All the administrative tasks will be performed in our cloud data centers. Now it'll be the responsibility of the service provider to monitor the utilization of the resources that will be needed to run the workload. And what it will be very powerful will be the ability to automatically adjust to it accordingly to whatever needs will meet the demand of the workload. That is true, powerful scalability. It's also the responsibility of the service provider to maintain the servers that are running the databases and the application by ensuring that all security patches are applied and maintaining them. The Oracle Cloud Administrator will maintain the hardware as well as the software so they are not outdated without ensuring that there will be any impact on you to make sure that your business is always running and that what is needed to run your business, like the servers, the security, and the database and the application, they're always up and running and ensuring that there will be no impact on you is a true form of flexibility. As we're running on the latest and greatest in terms of the hardware as well as the software and ensuring that all security patches are always applied, we will be able to upgrade your server. And the cool part of all this, because we're current with everything, we can do it online. And that's one of the considerations that you could not do with older hardware. So having the ability to upgrade your server online will then be a true, not impact rather, to your environment. And that is a strong consideration of running in the cloud to allow upgrade on server while online. Continuing that concept of maintaining the security, the hardware, and the software aspect, that will be then to ensure there's absolutely no compromise to the security, compliance of your company, the performance of your environment, the hardware and software will then help you lower your cost. Providing access to the resources, be it the server, the database, or the application, through various web-based tools as well as command line tools, can all be done easily using the cloud. We'll take advantage of our identity access management by taking advantages of the policies that we will use to grant accessibility very easily. Another consideration for using the cloud in the concept of accessibility is to be able to access your environment from anywhere. All you need is basically internet connectivity. By running your database in the cloud, your downtime is decreased. You have new tools and applications that are implemented much faster. You can develop and run database intense cloud native applications. The cloud service provider will take care of the system updates, the software patches, and will make sure that your cloud infrastructure meets the compliance requirements. And that will help in your availability to your resources. Having this configuration creates a multi-cloud environment. You can then take advantage of all the cloud service providers that you have and now run it all within your Oracle environment. So let's take a look at the supported types of database services. The Oracle database supports mission-critical online transaction processing application as well as intense analytical processing. A non-Oracle database such as MySQL provides an open-source relational database management system. A NoSQL database provides you a fully managed database service of a distributed key value database for developers who wants to focus on the application developments. With external database, it allows you to use the cloud-based tools such as database management with your external databases. External database can be used for both on single instance database as well as rack databases, your two-node applications. So this provides you the ability to have your Oracle database outside of your Oracle Cloud infrastructure, but still being able to maintain it with the Oracle Cloud infrastructure tools. In this lesson, we learned about the considerations of running a database in an on-premise environment as well as in the cloud. We also learned what are the supported types of Oracle databases. Oracle Cloud Infrastructure, OCI Database, Oracle Databases. In this lesson, you'll be introduced to the different types of Oracle Database Services. Oracle Database Service on a virtual machine is a database service offering that enables you to build, scale, and manage full-featured Oracle databases on virtual machines. This service is available in Oracle Cloud Infrastructure regions around the world. With Oracle Database Service, you can efficiently run and manage any database workloads, regardless if it's a mission-critical online transaction processing environment or an analytical workload. Your Oracle database on the virtual machine can be a single instance or even a two-node rack environment. With our cloud automation, you have full control on how the database will be provisioned, how it will be patched, how it will be backed up, as well as implementing disaster recovery. The Oracle-based database service has two levels of services: Standard Database Service, which is based on the Standard Edition, as well as the Enterprise Database Service. You can deploy either the Enterprise Edition or the Standard Edition, and database versions 12c, 19c, or 21c using virtual machines, which are referred to as database system in the Oracle infrastructure. When you launch a virtual machine database system, you will select the Oracle Database Edition as well as the version. That will be applied to the database that is created on that virtual machine database system. A single database is created in the virtual machine with the database version that you selected. You have the ability to choose the appropriate number of OCPU that will correspond to the memory size that will meet your workload requirements. One of the key benefits of running the databases in the virtual machine are the ease of getting started and the durability and the scalability of our storage and ability to run real application cluster rack to help improve your availability. With the Oracle-based database service, you can manage the database instances by using any of our tools, for example, the cloud automation tools, such as the Cloud Infrastructure Console, the command line interface, or any APIs to help you provision, patch, backup, and implement disaster recovery. The virtual machines may share computing resources, but provide secure isolation for your database environments. You only have root access to your virtual machines. What is Exadata Database Service? The Exadata Database Service is a service that runs in the Oracle Cloud. It's 100% compatible with all the on-premise Oracle databases and all the existing applications. Because it's 100% compatible, Exadata Database Service allows you to take your on-premise environment and easily embark it into the cloud environment without compromising the database performance or availability levels that you currently already know and implement in your on-prem environment. So with these capabilities and all the features and options, you can take what you are already running in your on-prem environment, your mission-critical applications, your analytical workloads, and take what you already know about the Exadata database machine and have that capability run in the Oracle Cloud. You already know the Exadata database machine is the fastest and most available of all the Oracle database platforms. It is perfectly ideal and suited for cloud computing, so take what you are already running in your on-prem environment and run it in the Oracle Cloud. But now, as that Exadata database machine is running in our Oracle Cloud, there are no capital expenditures. You just need a monthly subscription. All the supporting infrastructure for the Exadata database service is deployed, maintained, and managed by the Oracle operation team. That includes the data center networking, the private networks, the physical Exadata database servers, as well as the storage servers. Your monthly subscription fee is based on your Exadata cloud infrastructure configuration, the number of enabled Oracle CPUs, those will be your OCPUs, in your system configuration. And remember, one OCPU equals to one enabled database server CPU core. The Exadata database service includes a easy-to-use web-based tool, a wizard, to help you easily, quickly provision an Exadata system, along with your database deployments. The Exadata database service provides a complete service isolation with no over-provisioning of the hardware to ensure that response time as well as throughputs are predictable for your most mission-critical business processing needs. So as it's 100% compatible to what you already have running in your on-premise environment, Exadata database service helps you easily take that into the Oracle Cloud. Oracle Autonomous Database is a fully managed database that is completely automated. It has two types of workload, one that is ideal for your online transaction processing and one that is more for your analytical needs, the data warehouse. When we speak of it is completely automated, we are talking about everything. We will make sure that it is automatically backed up to protect your database. We will apply automatically the latest and greatest patches to ensure that you have the latest features, and more critically, your security patches to make sure that your database is well protected. When there are features, we will upgrade your database. And cool part is, it is all done online. But one very powerful feature is tuning. You can always tune your database, but there are times we would like to make sure that it's running in the most efficient manner. For example, when you have users that are running executions of queries on your database, well, there may be times they may always query a particular table with a particular predicate clause, but we may notice there's no index on that particular column. So to help it run more efficiently, when there is a need for an index, we will automatically create it for you. An example of tuning. When it comes time to deploy your autonomous database, there are two deployment options. We have shared as well as dedicated. In a shared deployment, all operational decisions to the Oracle environment is all done by Oracle. This will provide you the ability to quickly provision your autonomous database and have it to be immediately productive. We will take care of everything. Oracle will handle the infrastructure, the deployment, as well as the management of your database. All you need to do is to create the users and provide them access to your data in the database. But even with all this wonderful automated capability, there are times you might want to have a greater control over the isolation of that infrastructure. It's great that Oracle can handle that infrastructure deployment and management, but there may be times you want to have that capability. You want to customize your maintenance schedule. You want to customize when you want to perform the update, as well as the backup retention time, for example. If that's the case, you might consider deploying it in a dedicated environment. With Autonomous Database Dedicated, this provides you the capability to have a self-service database within your own database cloud environment, regardless if that's running in our Oracle Cloud Data Center or even in your data center. In this lesson, we learn what are the different types of Oracle database services. Oracle Cloud Infrastructure, OCI Database, Base Database System Configuration. In this lesson, we will learn what are the configuration options for virtual machine database systems. Virtual machine database system options. When you launch your virtual machine database system, you have a choice of AMD Flex or Intel Shapes. This will be the type of processor for your database system. Virtual machine database systems are available in single instance or in a two-node rack database system on the virtual machines. A single instance or a one-node virtual machine database system consists of one virtual machine, whereas a two-node virtual machine database Exadata-based systems consist of two virtual machines on separate servers running the real application cluster, RAC. The two-node Oracle RAC database systems require the Oracle Enterprise Edition Extreme Performance license type. The maximum number of OCPU, its memory, and storage for your database on a virtual machine depend on the shape you choose. After creating your virtual machine database system, you can scale your OCPU. For AMD shapes with flexible OCPU counts, you can use the OCPU slider in the console to adjust the desired OCPU count for your VM shape. You can change in increments of 1 OCPU up to 64 OCPU. If you wish to scale for the Intel shape, which has a fixed CPU count per shape, you will need to change the shape of the virtual machine database system. It will require a brief outage. You can scale the usable block volume storage online for up to 80 terabytes of storage, and that is both for the AMD Flex as well as the Intel shape. The memory will scale accordingly with the number of OCPU, and that of the available I/O performance will scale with the amount of storage. If you are scaling OCPU with a two-node rack virtual machine, it is done in a rolling manner across the two virtual machines in the cluster, one virtual machine at a time. Shapes for virtual machine database systems. A shape is really a name that consists of a certain amount of resources. So as you see here, since we're describing the various shapes for virtual machine, our platform would be VM, virtual machine. Now for that shape of a particular name, it would consist of a certain amount of OCPU, which then will define the amount of memory. Remember, the OCPU will define the amount of memory. The storage up to a certain value, depending on the shape, and of course the network throughput, and depending if you're in a single node or a two-node rack environment. Here you see a listing of various shapes by their names and the type, be it a fixed or flex configuration, and the boundary of the resources for that shape. What we currently list is the OCPU and the memory for a particular shape. Now note, with a fixed VM shape, the OCPU shapes are available from a value of 1 to 24 OCPU, and the amount of memory is allocated at 15 gigabytes per OCPU. Whereas for a flex VM shape, think of your AMD, the OCPU can go up to 64 OCPU in an increment of 1 at a time, and the memory that is allocated per OCPU is 16 gigabyte of memory. As you increase the allocated OCPU, the available network throughput for your configuration will be displayed in the console. Do bear in mind when planning for OCPU scaling, you should remember you cannot scale the VM OCPU by changing the shape from a single instance to a two-node instance environment. Also, since the virtual machine database system uses Oracle Cloud Infrastructure block storage, you can specify the storage size when you launch the system, and then you can scale it up to the storage that is needed anytime online that you desire. So as you can see, a virtual machine shape really determines the amount of OCPU, memory, and the network resources that will be allocated to your database system. Virtual machine database system storage architecture. When creating your virtual machine database system, you have a choice of logical volume management, LVM, or grid infrastructure, ASM storage management. For a single node virtual machine database system, you can select logical volume management or ASM as your storage management. If you're creating a single node virtual machine database system and you choose logical volume management, it can be your storage management option to have a fast provisioning option. The default provisioning for a virtual machine database system is with Oracle Automatic Storage Management, ASM. When you select ASM storage management for your virtual machine, you will select Oracle Grid Infrastructure when you provision your virtual machine database system to use ASM. ASM will use data as well as the RICO disk group to store your data as well as your backups in your RICO disk group. An example of an ASM disk group allocation would be something like 80% for data storage and 20% for your RICO disk group storage. That depends on your configuration, but that's just an example. Since the block storage is already providing a triple mirroring of the data, the ASM redundancy is set to external. That configuration option is required if you are configuring a two-node rack database system deployment. Now, the database system clone is also supported not only for LVM, but also for ASM storage management. In this lesson, we learn what are the configuration options for virtual machine database systems. Oracle Cloud Infrastructure, OCI Database, Exadata Database Service. In this lesson, we will learn what is Exadata Database Service, what are the features of the service, and what is Oracle Exadata Database Service on dedicated infrastructure. In addition, what is Exadata Cloud at Customer. We'll learn what are the supported infrastructure for the Exadata Database Service, and what are its storage server and its OCPU scalability. Exadata Database Service is a database service that's deployed on either a dedicated Exadata in the Oracle public cloud or at a customer data center. It gives our customer the most flexibility to control many aspects of their database service. With our powerful cloud automation capabilities, it enables our customer to manage the system with minimum effort while still providing full access to the database instance, the database homes, and the grid infrastructure. Our customers have root access to the virtual machines in the Exadata database service, as well as full database administrative privileges for the databases they provision. Lifecycle operations for the Exadata database service are performed using web browser user interface or the REST APIs, and that's available through the cloud control plane, including provisioning capability, update, scaling, as well as backup. Operating system as well as database updates are applied by the customers based on their preferred schedule. The underlying Exadata infrastructure is deployed, monitored, and managed by the Oracle Cloud Operations team. Customers can set their time preference to determine when the infrastructure maintenance windows can be. With Exadata Database Service, our customers are charged based on the OCPU allocated to their VM cluster. And our customers can even scale their OCPU online and pay only for the processing power that they need. Exadata in Oracle Cloud, the most complete database service available. When you take a look at our Exadata in the cloud, it provides the most complete database service that's available. The consistency of our database feature across all our Exadata deployment allows you to have easy portability of your database from your on-prem environment into our Oracle Cloud. On the right, you see some of the Exadata innovation that are available with the Exadata platform, including our recent additions, such as the persistent memory and our 100 gigabits RDMA over our converged Ethernet. Our RDMA over Converged Ethernet or InfiniBand over the Ethernet is really a network protocol that allows remote direct memory access, that's the RDMA, over the Ethernet. On the left are some of the key features available in the Oracle database that you're most familiar with: the multi-tenant, the Oracle RAC, the partitioning, the Active Data Guard. When the Exadata database service is deployed with the license included, the OCPU licensing model, all these key capabilities are innovations that is already included. Dedicated infrastructure. Oracle Exadata database service on dedicated infrastructure provides Oracle's Exadata database machine as a service in an Oracle Cloud Infrastructure data center. The Oracle Exadata database service on a dedicated infrastructure instance is really a virtual machine cluster that resides in our Exadata racks that is in our OCI, our Oracle Cloud Infrastructure region. Each instance of the Oracle Exadata database service on the dedicated infrastructure contains multiple database servers and the Exadata storage servers. They are connected by a high-speed, low-latency network. The Exadata, along with the storage rack server, resides in an OCI, the Oracle Cloud Infrastructure region. Cloud at Customer database services. You have the capability of the Exadata database service running in our data center, but you also have the Exadata database service running in yours. Exadata Cloud at Customer gives you that simplicity of the security as well as the control of running Exadata in your data center. It's co-managed by Oracle and an autonomous database, and both are offered with a subscription model. So with Exadata Cloud at Customer, you have the deployment of Exadata, but at your data center. So now with Oracle Exadata database service on Cloud at Customer, you can manage absolute control over your data while taking advantage of the combined capability of Oracle Exadata and the Oracle Cloud Infrastructure that is managed by Oracle. You have full access to the features and the capabilities of the Oracle database, along with the performance and the scalability of Oracle Exadata, but with Oracle owning and managing the Exadata infrastructure. You can use the Oracle Cloud Infrastructure Console and APIs to manage the Oracle Exadata database service on Cloud at Customer, just like you would with any other cloud resources, while maintaining absolute sovereignty over your data, as the data is now residing in your data center. For our database service options, you have Exadata database service at Cloud at Customer, as well as autonomous database at Cloud at Customer. Supported infrastructure, X8 and X9. The Exadata Cloud Infrastructure X9M is even more cost-effective than X8M. It provides you with even more compute, storage, and faster networking capabilities. It provides 2.5 times processing cores and 28% more storage capacity and even faster networking. The share client and backup network is now twice as fast, 2 times faster rather, offering up to 50 gigabyte bits than before. The PCI enables a full 200 gigabits aggregated bandwidth of an active to active Rocky Fiber. The Exadata Cloud at Customer offers the Exadata system in the following shapes: the base system, the quarter rack, the half rack, as well as the full rack. Exadata storage server. The storage space inside the Exadata storage server is configured for use by the Oracle's Automatic Storage Management, the ASM, when you launch your Exadata Cloud Infrastructure instance. There are two disk groups that are created: the data disk group as well as the RECO disk group. The data disk group is for storage of your database data files, where the RECO disk group is primarily used for storing the fast recovery area. This is where you have your backups, your for recovery, your RMAN backups, your archive log files. If you create Exadata snapshots, you also create something called a sparse disk group, and that's where those snapshots will be stored. The configuration of the data disk group, as well as the RECO disk group, and also the Sparks disk group, is dependent. It depends on whether or not you have database backup in the Exadata storage, as well as the Exadata snapshots. So just a simple example: if you have database backup on Exadata storage to be set to no, and you have Sparks disk group to be set to no, then your data disk group will be 80%. Your RECO disk group will only be 20, since your backups will be stored somewhere else, for example, in Object. And since you have no Sparse disk group, then it'll be 0. So it'll be 80 for data, 20 for RECO, and 0 for sparse. But if you desire to have your database backups on your Exadata storage, and you also want to have a sparse disk group because you wish to have snapshots, then you may see something of a configuration of 35% for your data, 50% for your RECO, and 15% for your sparse. OCPU scaling options for Exadata database service. As your business grows and your workload increases, you may need to scale your Exadata database service OCPU capacity. Your Exadata CPU can be scaled in the following manner. If the Exadata database service instance requires a change in compute node processing power, you can scale the enabled OCPU up or down online in multiples of the number of database servers that is concurrently, or I should say that is currently provisioned for the Exadata VM cluster. You can even scale the Exadata database service instance down to 0 enable OCPU. With your 0 enable OCPU, you are built only for the infrastructure until you scale up the system. Exadata OCPU capacity can also be scaled beyond the capacity of the existing servers. Within a single Exadata database service, you can provision additional resources needed for your workload with any combination of 2 to 32 database servers and 3 to 64 storage servers. The flexibility of the X8M as well as the X9M is designed to easily scale in place, so there's no need to migrate the database to another larger system. You can scale OCPU by simply adding compute servers to the Oracle Cloud infrastructure using the OCI console or even REST APIs. To learn more about the Exadata database machine and even become a certified specialist on the Oracle Exadata database machine, go to the link that you see here and go to My Learning to learn more about this training. In this lesson, we learn what is Exadata database service, what are the features of the service, and what is Oracle Exadata database service on a dedicated infrastructure, what is also Exadata at Cloud at Customer, what are the supported infrastructure for the Exadata database service, and what is the storage server as well as its OCPU scalability. Oracle Cloud Infrastructure Demo: Launching and connecting to a database system. In this demo, you will see how to launch a database system and connect to the database of that database system. Now recall, before we launch our database system, we want to make sure that there's a few things in place. We want to make sure we have access to a compartment, which is really a collection of related cloud resources. We also want to make sure that if we don't have one already, that we create a virtual cloud network. This is where we will launch our database system. And as part of creating that database system, we need to make sure we have a public key. Let's log into our cloud tenancy and go and create a virtual network if we don't have one already. I click on networking, going to my virtual cloud network. I make sure I define the compartment that I wish to create the virtual cloud network. In this case, my compartment name will be my demo. You may notice I don't have a virtual cloud network yet, so I will create one. I will use the VCN wizard, which will easily help me create a virtual network. Using the wizard, I say start my VCN wizard. I may choose to create one for internet connectivity from a site to site, such as using VPN, but for now, I'll just create a VCN with internet connectivity. I click on start my VCN wizard. It will then ask me the following: to provide a name for my VCN. I already selected my compartment, so I will give it a name. I give my VCN name of OU class VCN. I confirm it's in the compartment that I desire, and I will then take all the default of how my VCN will be created. Now here, even though I took the default, it's always a good idea to become familiar with what you're creating. So at any time, you may notice there's a lot of what we refer to as bubbles in our wizard. You may always mouse over it, and you can see explanation. This is an example of how many of IP addresses I may desire to have. That would be my collection of IP addresses. For now, I will take the default. You have an option of the type of IP addresses. And for the purpose of this demo, I will choose IPv4. I do want to leave it with the DNS. This way I want to have the advantage of domain name service if I wish to use the instance hostname as part of my assignment. So I leave it checked. Scrolling forward, I will want a public as well as a private subnet. I will leave it as its default. I click next, and it asks me to review and let it create. I will take a moment to review what it will create. And you can see it is not only my VCN, the subnet, both private as well as public, and gateways to allow me to connect to the internet, to connect to the services, for example, if I need to get to my object storage, and for security lists, along with my route table. But for now, let's just create it. You can see how quickly it is created. We can view what we created. And here you see all the information of the VCN I created. So now that I created my virtual cloud network, I'm ready to launch my database system. Going back to my navigation menu, I now select my Oracle database. And from here, I choose to select the Oracle Base Database Services. I now may create my database system. And again, confirming the compartment I wish to create the database system in. Confirming that I am pointing to the compartment I wish to create my database system, I see it here, as well as up here, I would then click on Create Database System. It will bring me to the first dialog page. I give it a name after confirming my compartment, and I will give it a more descriptive name. I choose to create the name of my database system to be OU DB for database system, and it will be my first database system. I would desire to be created in one of the 3 availability domain for my region, and I can confirm my region. So I will take the default, as you notice already checked, of availability domain 1. For my shape, it will be either a virtual machine or bare metal. I choose virtual machine, and that will bring me to shape. Now recall, a shape is really just a word or a name that will define the configuration of the amount of resources that you want your system to have. And here you see the type of processor and the amount of resources. Again, for the purpose of our demo, I'll just change the shape and ask it to have a little bit less a number of OCPU. But this should be according to your workload. And you may also notice that for our shape series, you have a choice of 2 different type of processors. So again, for the purpose of our demo, I'll just reduce this to 1. Okay? I select the shape I change, not just the name, but the configuration. And I'll scroll down a little bit and take us to our next configuration, which will be the storage. Here you choose the storage management software type that you desire, be it grid infrastructure or logical volume. Now you may notice that it's already selected grid infrastructure for you, and it's ideal for certain type of configuration. Think of high performance. But again, for the purpose of our demo, I'll just make it a little bit simpler and ask for logical volume management. And this is ideal if I'm trying to prototype something and deploy something that's very quick and easy. I select that, and again, for the performance, I can have it to be balanced or high performance. That should be a decision of yours, depending on your workload. Again, for simplicity of this demo, I'll just choose balance. It will define what would be my available storage space. So again, understanding the configuration for your database, and I would just save the changes I made. Scrolling down a little bit more, the number of nodes. I may ask for not just 1 node, I may choose 2, for example, for a rack, a real application cluster. For the purpose of this, I would just leave it at 1. Then comes my software edition. Now remember, this will then determine the amount, or I should say not the amount, but the type of features that you will have for your database system. Again, for the purpose of the demo, I'll leave it at high performance. I may not need the active data guard and so on. But again, consider that if you are provisioning, launching for your environment. I'll leave it at high performance, and it will come back and you notice this is grayed out depending on the amount of storage I provided before. It will then determine what is the total amount of storage that I will have for my database system. Continuing to scroll in our dialog box, the next thing would be our SSH key. Now, this is how we will authenticate ourselves to connect to this database, the database in the database system. Again, for security, we will associate a key when we provision this database system, and we will have another key, and that will be used to authenticate you when you connect to the database. So here you see an option. You can generate a new pair, you can upload an existing key that you already have, or you can paste the content of the key. For this demo, I'm going to generate a brand new key pair. You notice one of the things is I need to save my private key. That's the key that I will use to authenticate myself to the database when I'm connecting to it. So I click on this, and it will download that to my local system. If I so desire, I can also save the public key. So now I will end up having a key pair. And if I so desire, I may desire to use these 2, the key pair, on another database system. Again, this is your security consideration. It is not Good or bad, you may wish to use the same key pair across many databases, again for simplicity, but not necessarily a very strong security configuration. But if you're just prototyping for something simple and just want to see something like a proof of concept, maybe that's a consideration. So for now, I will not save the public key. You can have your license included, and that will then generate a new license for this database system. Or you may bring your existing license. So suppose you already have licensing that you use for other database system, be it for the cloud or even in your on-premise environment. If you want to use that same license, you click on Bring Your Own License. For the demo of this example, I will click on License Included. Now bear in mind, that means you will have a new license for this database system. The next thing it asks would be my network. And you notice every time I click over something or mouse over something, it will then pop open a dialog box to provide me more information. Here I provide information about my network. I can use the dropdown to select a network that I created. I may have created others, but in this case, for the one that is in my compartment, I created a virtual network before, and that's the name of that virtual network. Then I will choose a subnet, be it a public subnet or a private. For security reasons, we do encourage a private, but again, for my demo, I'll make it public. Whether or not you wish to choose to have a network security group. Now, a network security group is really a capability to provide a virtual firewall for a set of cloud resources. In this case, think of your database, and that really have the same security requirements. Think of the following. You have a group of either compute instances or databases that performs the same or similar tasks, and thus all need to have this use of the same set of ports. You may then associate them all to one network security group. For the purpose of this demo, I'll just leave it unchecked. Next is the field hostname prefix. When creating your database system, it is really mandatory you provide a hostname prefix, though it really doesn't tell you you need it. You do. The prefix forms the first portion of the database system hostname. The database system hostname domain name value is really automatically assigned based on your virtual cloud network and is subnet fields. So that means the database system name will have a fully qualified domain name based on the hostname prefix. So as the database system fully qualified domain name is based on this hostname prefix, you need to provide a hostname prefix. Now, I've entered in my hostname prefix. I want to draw your attention to the next two fields. They're read-only fields, but you may notice the naming convention specifically here. Notice there is my OU class DB host. That's my prefix. So you see it now becomes part of my naming convention, part of that URL. Scrolling down in the dialog box is asking for diagnostic collections. And this is very important when you do provision your environment. So make sure that you enable for diagnostic environments, or events rather, and enable that logging capability. So I will leave it checked for now. Okay? You can show other advanced options, specifically if you want to do tags, if you want to change any of your time zones. But for now, I'm just going to click next. That'll bring me to the next dialog page. And the first thing it's going to ask me is a unique name for my database. Now remember, this is a database in my database system. I give my database a unique name. I may ask for an optional unique name for the suffix, as well as a database unique name if I so desire. I will leave those for now, but I do want to use a particular image for my database. Now, an image, think of it as a template. This is the template of the database you wish to create. It shows 19C for now, but if I so desire to change it, I have the following option. I may use any of Oracle's predefined database images, or I may create my own. In addition, I may use not only the predefined images, I may have a version I may desire. So for example, I may choose to have 21C. Whatever changes I make, I select the changes and accept it. I continue if I wish to have a pluggable database name. But for now, I will forgo that, but I do need to provide a password for my administrator, in this case, for user sys. I enter in my password once, but it asks me to enter it again. It asks me the option, do I wish to use this password for my wallet, my TDE wallet, for my encryption? And I choose yes. Next, it asks me, do I wish to configure for automatic backup? So here I have that option. Do I wish to put it in object storage? And again, what would be my retention options? For simplicity, I would choose not to have automatic backup. I may change that going forward. Now that I have done all that, it's asking, are you ready to create your database system? I click yes. It is now in the status of provisioning. So it's now in the process of creating my database system. Let's give it a little time for it to complete. The creation of our database system has completed. You may notice that the status went from provisioning to available. As you may see on the database system details page, you can see information about your database system. You may perform various tasks on your database system. And from the database system information tab, you can see general information about your database system, as well as the version and the network information. Now, if you go straight down on the left side, you will see under resources more information about the database for this database system, how many nodes of your databases you have, metrics information, console connection if you want to connect to the database. With console connection, you can associate another pair of keys to connect to this database. So remember, when we created this database system, we associated a pair of keys. The private key is what you will use to connect to the database. But what if you want to associate another pair of keys to use to connect to this database? You address that with the console connection. And with work request, you can see what work request has been asked of this database system. We already done one together. That would be the launching provisioning of this database system. Now you may notice that under resources, one of the things would be the database. So now that we created our database system, let's connect to our database. So since we only have one node, let's click on this, and it'll bring us to the details page of that database. Now, remember, you'll see this message because one of our options that we provisioned the database or database system with was that we did not want it automatic backup. That was our decision when we provisioned it. But from here, you can see more information about your database. Very similar, you have tasks you may perform, information about the database, and as always, go under the resources and you'll see various information, more information about backup, the database association, and so on. But I'm going to go back to the database system page for a moment. And going back to resources, you may notice for this database, it gives you more information, but I want to connect to one of the nodes. And since we only asked for one node, that would be this. So here's my name of my node, and you may notice I have an IP address, both public as well as private. I'm going to use this IP address to connect to the database. So this is how we will connect to our database. I will copy this IP address, And then I'll go to a utility or tool that allow me to connect to the database. As I'm in a Windows environment, I may use something like PuTTY. If I'm in a Linux environment, I may use SSH. I bring up my tool, PuTTY, and I copy the IP address. And that's the same IP address you see here. But I need to provide it some other information. So one of the information I need to provide it would be my private key. Go under connection using this method. And under SSH, since that's what I would use to connect, I provide information. And in this case, I provide my authentication. It asks where would be my public key, or I'm sorry, where would be my private key. I browse to the location of my private key. And once I provide that file, I can click open. You may notice that it provides the following information. Since the key information has not been cached, think of it as this is the first time that you open it or you're using it. It's letting you know that it's never been used before, but do you trust it? And if you click on the accept or connect only once or cancel, it's your discretion. So I will click on accept. Once I do that, you notice that it will ask me for a login. You may recall you cannot log in as user root at this point. You need to log in as a username that was created for you to connect to your database system, and that would be user OPC. Congratulations, you're now connected to your database. Now, do bear in mind, since I don't know the version of your tools, your PuTTY or your SSH, if you ever see a message that says old SSH format, you may need to generate the key using the tool to generate a new version. Otherwise, you should be connected. Here, you may notice, since remember, you are using Oracle Linux, this is nothing more than a Linux environment. From here, you can connect to as user Oracle or any other operating system user, if you create others, in order to connect to your database. Now that we're connected to the box, if you can think of it in that sense on the operating system, I'm still user OPC, so I need to connect as user Oracle, as you would on the operating system to get to your Oracle database. Let us do that together. I would sudo, and then I would switch user. In this case, I want to switch to user Oracle. Here you see that I'm logging in as user Oracle. And if you just take a look at my working directory, you can see I am in /home/Oracle, and I am user Oracle. From here, you're on the operating system of the box of the server that is running your database. Congratulations. Not only have you connected to your database, or you will using any of the tools, you connected to the box that's running your database. In this demo, you not only launch your database system, as part of creating that database system, you created a database. From here, we see how using the SSH private key, you connected to the server box that's running your Oracle database, and we even see how we can connect to user Oracle. This concludes our demo. Oracle Cloud Infrastructure, OCI Database, Base Database Managed Features. In this lesson, you will learn what are the prerequisites for launching a database system, what are the scalability options, and what are your backup and recovery options, what are the features in cloning, and what is a performance hub. You'll also learn what is a custom image and why you would consider using one. Launching a virtual machine database system. Before we can launch our virtual machine database system, we will need the following items in place. A public key in the open SSH format will be associated to the virtual machine database system at creation time. This public key is from a key pair where you will also have a private key that you will use for connecting to the database system via SSH for authentications. Appropriate identity access management policies are also required, and a tendency that is needed to have the necessary service limits for you to create your virtual machine database system. A virtual cloud network must be created in the region where the database system will be launched. Its related networking resources, such as gateways, route tables, security lists, must also be configured as necessary for the database system. For example, you need to consider configuring for an internet gateway if you desire to have object storage for where your backups will be stored for your database. In addition, you need at least one public or private subnet. That is required. Oracle recommends a private subnet for security purposes. In addition, if you are considering to create a two-node rack virtual machine database system, ensure that the port 22 is open for both ingress, that would be the inbound network rules, and egress, that would be the outbound network rules on the subnet. You also want to make sure the security rules that you create are stateful. Otherwise, the database system might fail to provision successfully. If you plan to back up your database system to object storage, or you wish to use the managed patching features, you will need to address object storage as one of your storage options. You will also need to make sure you have access to a compartment. Now, a compartment is really a collection of your cloud resources. The database system is created in your current compartment, and you can use the network resources in that compartment. Policies will be enforced for security and isolation purposes to ensure that you have access control so that only those things that are allowed to be accessed by a user will be the only things that's accessible to that user. Scaling your virtual machine database system. How you change the number of CPU cores for the virtual machine in your database system is very dependent on the type of cores that you assigned when you created the system. For example, if you launch your database system with the flex shapes, that would be the AMD processor, then when you desire to scale it, then you can scale in increments of 1 OCPU at a time for up to 64 OCPU. But if you desire to scale the OCPU with a fixed OCPU shape, think of the Intel, then that will require you to change the shape of the system. Now remember, the shape is really a name that you give to the configuration of the amount of resources that you assign to the system. But you will need to change that shape if you desire to scale in a fixed OCPU. If that's the case, the virtual machine will need to be rebooted when the shape of the VM is changed. In a two-node rack environment, the shape of the VM will be changed and will be rebooted once for each of the VM, and it will be done in a rolling manner. Storage scaling is available for the virtual machine database system, and it should be done separate from the OCPU scaling. If your virtual machine database system requires more block storage, you can increase the storage at any time online without any impact to the system. You can scale the data area size. Think of your data disk group, and that's independent of the recovery area size. Think of your Rico disk group. The storage size that's used by the virtual machine database system is determined by the amount of available data storage and the recovery area storage that you select. Once assigned, the available data storage size cannot be decreased. And for the recovery area storage that is used to store your backup and recovery files, it also cannot be decreased once it's assigned. To scale storage or increase it for your virtual machine database system, go to the details page of your database system and click Scale Storage. And then from your drop-down list, select the new available data storage size and recovery storage size that you desire and just click Update. Backup and recovery. The Oracle Cloud Infrastructure Managed Automatic Backup features is the preferred method for backing up your Oracle Cloud databases because you can easily configure backup settings using the console. The automatic backup feature supports the recovery service and object storage as the backup destination to provide you a fully automatic cloud backup solution. The Oracle Cloud Infrastructure Object Storage is used to back up your virtual machine database system databases. You can use the console or APIs to enable automatic incremental backups or create full backups on demand. All the backups are encrypted with the same master key that is used for your TDE, your transparent data encryption. In order for you to be able to access the object storage for your database backup, we recommend that you take advantage of the Virtual Cloud Network Service Gateway to enable the access to your object storage. You can use the console at any time to manually delete any backups that you don't desire anymore. When the database is terminated, when you delete the database, all the backups, the automatic backups that was created, will also be deleted along with the database. Any full manual on-demand backups that you created in object storage will remain in object storage. This is even after you terminated the database. Now remember, the database must be in available status for the backup operations to run successfully. Oracle strongly recommends that you avoid to perform any administrative tasks that might interfere with the availability of the database. Consider something like patching your database while you're trying to do a backup. For whatever reason, if the automatic backup operation fails, the database service will retry that backup operation the next day during its backup schedule window. If you're attempting to do an on-demand full backup and that fails, you can try the operation again when the database becomes available after it's restored. To avoid any backup failures, make sure that the database is in archive log mode. In addition to storing your backup in object storage, you also have an option to store it in local storage. Now, local storage is where your database is stored. So basically, your backups are stored along with your database. Think of your fast recovery area for your database system. Now, obviously, this is optimized to have fast backup and have a fast point-in-time recovery. But do be aware, we mentioned together that this is stored along with your database system. So if your database system becomes unavailable, your backup is also unavailable. So it would be okay maybe to consider both your logical, or I should say not logical, local storage, along with your object storage. Cloning. Cloning creates a copy of your source virtual machine as it exists at the time of the cloning operation. Performance Hub displays information about the performance of your database for a time period that you specify. Think of a boundary from a particular time to a particular time. It provides you real-time information as well as historical performance data. To use Performance Hub for a database running on the base database service, Exadata Cloud Service, or database managed with the external database service, you must enable database management for that database. In addition, you need to make sure you have a policy that is created that will grant the users access to the Performance Hub in the Oracle Identity Cloud Service. To enable database management for the database in Oracle Cloud, you need to go to Observability and Management in your navigation menu. There are two options for database monitoring: basic management and full management. In basic management, your Performance Hub only displays the Ash Analytical and SQL monitoring tab, whereas in full management, the Performance Hub displays all the tabs that describes all the activities of your database. Custom database software image. When you launch your database system, you have an option to use a software image that is provided to you, predefined by Oracle, or you may use a custom image that you created. Custom database image are ones that you created for a specific reason. You may wish to have an image of a particular database version, release updates. You may wish to apply all the patches. You may wish to have a particular database home with specific inventory, certain modules. Or you may then have it to be very specific to match a particular need of your business. For one particular department, for all the databases of that department or that group, you may use one particular image, but you may have a different one for another department. You can then use this custom image that you created to either create new databases or update your existing databases. In this lesson, we learn what are the prerequisites for launching a database system, what are the scalability options, and what are your backup and recovery options. You also learn what are the features of cloning and what is a performance hub. You also know what is a custom database image and why you would consider using one. Oracle Cloud Infrastructure Demo. Database cloning. In this demo, you will see how to clone a database system with an existing database system and then connect to the database of that cloned database system. There may be times you wish to have a copy of your existing database system. You would like to have another copy of it because you want to test something, you want to prototype something, or you may wish to have a backup as it exists at that moment. But whatever be your reason, cloning would be your answer. Cloning creates a copy of the source virtual machine database system as it exists at the time of the cloning operation. Now remember, when you create a clone, you will need to specify a new SSH key and a new admin password. Logging into our Oracle tenancy, let's go to our Oracle database. Going into Oracle Base Database Service. In the compartment I have my database, I see I have my existing database system. On the database system details page, my database system is available, and you see one of the options that I may perform is clone. Here you see various information. You see information about your existing database, that would be your source database system. You will then ask to be configuring your new clone, your database system, the compartment it will exist in, and a name, giving it a descriptive name. So here is my descriptive name. Scrolling down, remember, you need to give it a new SSH. So I will do the same as I did when launching. I will save my private key for this database system. Now, remember, this is another database. So would you like to bring your existing license or use a new license for this database system, which I have to check? It still has to be associated to the network. So select the network you wish this clone database system to be in. The subnet. I do not wish for the network security group, but I do wish to have a prefix. I provided the hostname prefix. As you may recall, it will be part of my naming convention. I am providing no additional information for the other things. I do care for the diagnostic information to be available to me, so I keep it checked. Here's the name of my database. Now remember, this is a clone, so it will take on the name unless I give it a different name. And for now, I'll keep it the same because I'm more interested in the clone of the system, not necessarily a clone of, not necessarily a different name for the database. So I will keep it the same database name, or I can give it differently. But I do need to provide it a new administration password. I enter in the password twice. I do not need additional information. And now I click on Clone Database System. And you may notice, in a similar manner before, there's my clone database system name and it's in the status of provisioning. Let us give it some time to complete the creation of this clone. The creation of our database system